Hello students, today's topic that is right hand thumb rule. Before it I explain many points related to the magnet. Like that, or a study experiment, how can you find out direction of magnetic field by the help of magnetic compass. Okay, but this time I will discuss with you all one basic and important things. Magnetic property. Magnetic property comes into the natural magnet only due to the one fixed alignment of the molecules, right? Or magnetic properties comes into the metal only after passing electricity through it. When you will pass electricity through it, electrons will get particular fixed direction. Due to this, the wire or metal will behave like a magnet. Okay or not okay? Simply, we have natural magnet. In the case of natural magnet or any another magnet, electrons or molecule direction will be in a particular or fixed direction. Okay, due to this, it is showing their magnetic behavior or magnetic property. Okay, second thing, today's topic, that is the right hand thumb rule. Clear? In the case of right hand thumb rule, you will take your right hand. First of all, this rule is helping. Number one, for finding the direction. For finding the direction of current. Second thing, it is helping for finding the direction of magnetic lines. Left hand we will not use, only right hand is required for it only, right? In the case of right hand, you will take help of your fingers and you will take help of your thumb only. What will you do in this case? Simply, if a current carrying conductor is imagined to be held in the right hand such that the thumb points in the direction of the current, then curled fingers of the hand indicate the direction of magnetic field. Simply, if you have a wire, okay, you will connect. Simply, we have two ways to pass electricity through this wire. One way can be there, we can send electric current upside direction. Second way is here, we can send electric current downside direction. So we know that simply when electrons will pass through this wire, all electrons will get particular fixed direction, or this particular fixed direction, magnetic field will come around it. Okay, this wire will behave like a magnet. How it is possible and how we can find out the magnetic field line direction? What will you do? We will hold this wire into our hands only, like it. We will catch this wire like it. Okay or not okay? We can take example of this pen. Simply, we have this pen. We are holding this pen in our hand as same like it. This can be wire, na? So we can say from downside electricity comes and moves where upside direction only. When you will hold this wire like it, you can see current is moving towards your thumb. Clear? Or this hand means fingers will show here magnetic field lines. What are magnetic field lines? So we can say there current will move upside or magnetic field lines will be as same like it. Okay or not okay? If current is moving upside, so around it we will get different magnetic lines in the form of concentric circles. Okay or not okay? All are equally aligned with proper separation. Okay or not okay? So we can say if current is moving upside direction, upside direction. Hold this wire in your hand and simply you will see their magnetic field as same like it. Okay or not okay? Simply you can perform this experiment at your home also. Our wire should be properly insulated. Clear? Or in this case current is coming downside, so you have to take your right hand again. So you can see current is coming downside, means your thumb direction will be where? Downside, or your finger will be where? Most upside. So magnetic field will be as same like it, means opposite of it. So different concentric circle can be here as a magnetic lines. So current will be where? As same like it. Okay or not okay? You can perform this experiment at your home also with proper insulated wire for finding the magnetic field. Okay or not okay? One thing you have to keep in your mind, electricity will move only from positive terminal to negative terminal. This is the conventional current, or this current our main current. Okay or not okay? Many things you can include. Basically I discussed here only about the straight line wire. So when you will pass electricity through a straight line wire, you can find out the direction of electric current as well as you can find out the direction of magnetic field. Okay or not okay? So we can say this is the simple explanation of the straight wire like a conductor. When you will pass electricity through it, and you can find out the magnetic lines. Okay. Second point, second part of it. Magnetic field. Magnetic field due to a current passing through a circular wire. Circular wire or loop, both have the same meaning. Those wires which can be in the form of circle only, so we can keep this loop, this wire, circular wire in category of loop. Okay or not okay? So you can include in many cases simply if you have a wire in the form of circular loop. Clear? So we can say simply, first of all I'm explaining the things by taking half circle. So we can say this is our wire. Clear? This is showing here half circle. So if you will discuss about half circle, then you can discuss about easily remaining half circle. Okay or not okay? When you will connect this with battery, anything else, we can say current is moving upside through this wire and current is coming downside from this side. Okay or not okay? What will you do? You will select a particular fixed point on it and you will hold this point in your hand. Okay, we can say current is moving where? Upside direction. So magnetic field lines will be as same like it. You can do it with yourself. Magnetic field lines around it as same like it. Okay or not okay? Yes, a magnetic field lines should be as same like it. Okay, and second thing, when you will catch this wire from this point, what will you see? You can see there current is moving downside, so magnetic field lines should be as same like it. Okay or not okay? So we can draw here different concentric circles. Okay or not okay? So in this case magnetic field lines be as same like it. Okay or not okay? In this case as same like it, in this case as same like it. When you will see magnetic field lines moves towards it and magnetic field lines moves from this side to this side, so you can get magnetic field lines as same like it. But at the center you will see there the magnetic field lines getting their straightness, and at the center magnetic field lines will be totally straight. Okay or not okay? Not a circular. Because we can say that influence of it here also, then total influence nothing you will get, so simply you will get only straight line, straight at the center. Okay or not okay? So we can see here the different magnetic lines arrangement in the case of circular conductor or in the case of straight line conductor. Okay, देखो this is the diagram. How will you hold the wire in your hand? Simply see here. This is your hand. You are holding the wire as same like it. You can see current direction is where? Upside. And your finger will show their magnetic field. You can see your finger rotating as same like it. Okay or not? Okay. So means we can see your thumb direction will show their current and magnetic field lines as same like in your nail side. Okay or not? Okay. So this is the simple diagram of for holding the wire into your hands. You can do practical at home also with insulated wire for finding the magnetic field. Okay or not? Okay. So this is the simple diagram for getting the magnetic field lines around a wire only. Okay or not? Okay. So this is the simple explanation related to the when you have a straight wire and for finding the magnetic field of a straight wire. This is the diagram of circular wire. Circular, when your wire is in the form of loop or circle, you can see current is entering through this side, moving away as same like it, and coming out from this side. Okay, we can say current is moving as same like it. Okay or not? Okay. Then you can select different points on it. I am selecting here 2 points. Number 1 point is this and number 1 point is this. Okay or not? Okay. I am holding this wire, current is moving upside as same like it. Okay or not? Okay. Magnetic field will be, which are given here in the diagram, magnetic field lines will be as same like it. Okay or not? Okay. And second thing, in this case also current is coming outside direction, means we can say current is moving your thumb direction, or your magnetic field lines will be as same like it. Okay or not? Okay. So simply you can see here magnetic field line direction. You can do practical things at your home also. Don't get confused and anything like it. And you can see here that near to this point, magnetic field lines are very close to each other. So we can see there is strong magnetic field. And when you will move away from this point to this point towards this point, we can see there the gap between the lines getting increasing. Okay or not? Okay. So at the center it becomes totally straight. We can say influence of this here and influence of this here are equivalent and very less. So we will not get any curve magnetic lines. Okay or not? Okay. So we will get here only straight line. What? A straight line. So this is the arrangement. This is the arrangement for circular rope. Circular rope which can be helping for getting the magnetic lines. Okay or not? Okay. Any doubt now? Okay. This is a simple explanation about the straight wire conductor and the circular wire conductor. Okay. One thing, this is very helpful for the next coming new topic. Okay. So few important points I am going to discuss related to it. One thing I am telling here. Simple see here. In this case, we are seeing here one thing. We can say if you will increase you will increase the current value through this circular rope. You will increase the current value through this loop. What will happen? Magnetic field directly proportional to the current. Magnetic field directly proportional to the current value, means when you will increase the current value, on that time you will get more and more closely packed lines here. Okay or not? Okay. So total magnetic field depends on current value. Depends on current value. Okay or not? Okay. You can say simply more current, more will be the magnetic field, less current, less will be the magnetic field. Second thing, magnetic field inversely proportional to the distance. Distance matlab means we can say if you are moving away from this point towards this point, okay, means you are moving away from the center. Okay, so you can see here magnetic lines are very closely, here also, but when you are moving away from it, the distance between the magnetic lines getting increasing. Okay or not? Okay. Here total we will get a straight lines, means less magnetic field, very less, low magnetic field. Okay or not? Okay. When you will away from the magnetic field center, so on that time you will get a less magnetic lines, means less magnetic field. Okay, so we can say their magnetic field inversely proportional to the distance. Third thing, magnetic field directly proportional to the N. What is N? N means number of turns. N means number of turns. Simply you can say here is only one circular loop. You can take one more also near to it. Okay or not? Okay. You can take one more also near to it. Many loop you can make. Okay. For one loop we will get that much, we don't know magnetic field. For second loop we will get also. Third loop we will get also. Then we will get a more stronger magnetic field. More circle, more loop, more will be the magnetic field. Okay or not? Okay. These 3 points you have to keep in your mind. Magnetic field value, direct magnetic strength or magnetic field value directly proportional to the current, inversely proportional to the distance, and distance means far away from the magnetic wire. Okay, means electrical wire where you will pass electricity. And third point is their magnetic field directly proportional to the n means number of loops. Okay or not? Okay. So these things you have to include in the explanation of it. Any doubt now? Okay, students.